Good morning! Today we're going to learn how to solve problems using trigonometric ratios and the Pythagorean theorem. We're going to be using academic language such as sine, which is the trigonometric function describing the ratio of the opposite side to the hypotenuse of a right triangle, cosine, which is the trigonometric function describing the ratio of the adjacent side to the hypotenuse of a right triangle, tangent, which is the trigonometric function describing the ratio of the opposite side to the adjacent side of a right triangle, right triangle, which is a triangle with one angle of exactly 90 degrees, Pythagorean theorem, which is the equation showing the relationship between the hypotenuse of a right triangle and the two legs of the right triangle. The equation is a squared plus b squared equals c squared. Before we get into the nitty-gritty of solving word problems, we're going to want to review our basic trigonometric functions, those functions being sine, cosine, and tangent. As you may recall, these functions only deal with right triangles. As you can see, I constructed the right triangle ABC over here. I also labeled this angle theta. This is just an arbitrary angle that I selected to reference in these functions. Our first function is the sine, and the sine of theta is going to be equal to the ratio of the opposite side over the hypotenuse, or AB over AC. Our cosine of theta is going to be the adjacent side over the hypotenuse, or BC over AC. And our final trigonometric function will be the tangent, and the tangent of theta is going to be equal to the ratio of the opposite side over the adjacent side, or AB over BC. Now there's a memory trick to remember these functions and their ratios that they correspond to, and that would be SOHCAHTOA. SOHCAHTOA meaning for sine, that's going to be the ratio of opposite over the hypotenuse. For cosine, it's going to be the ratio of the adjacent side over the hypotenuse. And for tangent, is going to be the ratio of the opposite side over the adjacent side. Now we're going to review the Pythagorean theorem, because this will come up in word problems. The Pythagorean theorem only deals with right triangles. As you can see, I constructed a right triangle here, and labeled the points A, B, and C. The Pythagorean theorem says that the square of the two legs of the right triangle, in my triangle A and B, equals the square of the hypotenuse, or little c. So the equation is a squared plus b squared equals c squared. Now let's practice using our trig functions on a word problem. Let's say it's a sunny day on the school grounds, and the sun is casting a shadow of the flagpole on the ground, and the angle of inclination from the shadow to the sun is 40 degrees. Now, say we measure this shadow, and the shadow is 31 feet long. We want to figure out how tall the flagpole is, so we labeled it x. If we look at the flagpole and compare it to its shadow, we can see that this is a right triangle. And since it's a right triangle, we can use a trig ratio to figure out how tall the flagpole is. 40 degrees is the angle we're going to reference, and its opposite side is the side we don't know. So we want to use a trig function that deals with the opposite side. We know the adjacent side, so that means we're going to use the tangent, because the tangent is the opposite side over the adjacent side. Plugging in these values into this function, we have tangent of 40 equals x over 31. Now we want to solve this problem for x, so we can multiply both sides by 31, and we're going to get 31 times tangent of 40 equals x. Now let's calculate this. We'll type into the calculator 31 times the tangent of 40 and get 26.01. So this means that the flagpole is approximately 26 feet tall. Now let's try another problem. A zip line in a forest that starts high in the trees is 865 feet long with an angle of inclination of 35.638 degrees. It ends at a platform in a tree that is 703 feet away. The ending platform is 14 feet off the forest floor. You have to climb up a vertical ladder to get to the starting platform, and we want to know, how long is that ladder? If we make a diagram of this situation, we can see that it makes a right triangle. This means we can use a trig function to solve it. Plugging in the measurements, we can see that we have the hypotenuse of this triangle and an adjacent side to the angle 35.638 degrees. We also want to make sure we remember this little distance here to the ending platform, because it's 14 feet and it will be important when we find our final answer. Now, we were given a lot of information in this problem. We were given the length of the hypotenuse, which was 865 feet, and the length of the adjacent side to the angle, which is 703 feet. All we need to figure out is the length of the opposite side to this angle. So we need to use a trig function that involves the opposite side. Both sine and tangent involve the opposite side, sine being the opposite over the hypotenuse, and tangent being the opposite over the adjacent. So let's try to work with both of them and see if we get the same answer. So applying sine to this problem, we have the sine of the angle, which is 35.638 degrees, equals x, the opposite side, over 865 feet, which is the hypotenuse. So we're going to want to multiply both sides by 865, and we'll get 865 times the sine of 35.638, and that will equal x. So let's calculate this. 865 times the sine of 35.638. And it says that this equals 504. Let's see if we get the same answer with tangent. So, using tangent, we're going to have the tangent of 35.638 equals x, the opposite side, over 703, the adjacent side. Like in sine, we're going to multiply both sides by 703. Let's calculate this. 703 times the tangent of 35.638. Whoa! It's the same thing! Both of these functions gave us 504. Well, let's triple check this. We can use the Pythagorean theorem to check it again. Because we were given two sides of the triangle, we can plug these values into the equation a squared plus b squared equals c squared and figure out what x is. Now we can plug in these values into the Pythagorean theorem. So we're going to plug in 865 in for c, since that's the hypotenuse, 703 in for b, since it's one of the legs of the triangle, and x for a. Squaring both of these numbers, we get these large values, 748,225 and 494,209. So let's calculate this. We're going to want to subtract 494,209 from both sides. And that gives us 254,016. So this value, 254,016, is going to be equal to x squared. Now, we want to square root both sides to figure out what x is equal to. So, taking the square root of 254,016, we get x equals 504. And that's amazing because that's what we found with the two trig functions. So, are we done? I don't think so. We only found the value for x. We need to take into account the 14 feet now. In each of these three methods, we found the value of x to be 504, but that's not the length of the entire ladder, only the length of the ladder for here, the opposite side of the triangle to this angle. There's still a little piece of ladder down here, and this is where we need to add 14 feet. So, let's do that. we'll have 504 and add 14 feet to get our grand total of 518 feet. And that's going to be the length of our ladder. So we solved this problem by using trig functions, but we also checked it by using the Pythagorean theorem. To solve problems using right triangles, we can use trig functions and the Pythagorean theorem.